Hi everyone, this is Karthika, Faculty of Physics working in SNS College of Engineering. Today I am going to give some explanation about the semiconductor physics. In that, we are going to discuss about the introduction, definition, properties of semiconductor, classification of semiconductors, difference between elemental and compound semiconductor, and then types of semiconductor. So we know that the solid material can be classified into three categories, which are called conductors, insulators, and semiconductors. So conductor is nothing but conduct electricity and heat freely, and insulator we know that will oppose or resist the electricity and heat, and which is the semiconductor conduct partially, so that allows partially the electricity. So we know the example for conductor. So conductor's example is nothing but any metals we can say, and for insulators we can have the plastics, woods and all, and semiconducting material is nothing but a special case. So semiconductors are material which have a conductivity between the conductors and non-conductors or insulators. So it is a special class of material which is very small in size and sensitive to heat, light and electricity. And it behaves as insulators at low temperatures and as conductors at high temperatures. These materials have two charge carriers, that is electrons and holes, and semiconductors can be pure elements such as silicon or germanium, so which will be used in diodes and transistors, or a compound form, so that is nothing but a combination of two or more elements, like gallium arsenide or cadmium selenide, so which can be used in LEDs and laser diodes. So next one is a definition for the semiconductor. So it can be defined in two ways, that is based on electrical resistance. So it is defined as the resistivity of a semiconductor is lesser than an insulator but more than that of a conductor. So its resistivity in the order of 10 power minus 4 to 0.5 ohm meter. So it can be again defined based on energy band theory also. Semiconductor has nearly an empty conduction band and almost filled valence band with a very small energy gap. So that energy gap will be nearly 1 electron volt, and the picture shows the energy band diagram for a semiconductor. Next one is the properties of semiconductor. So we know that the main concentration on a covalent bonds. So they are formed by covalent bonds and they possess the crystalline structure. So crystalline structure means that have a periodic arrangement of atoms, and they have a empty conduction band. So conduction band only responsible for a conductivity that will induce the electrons for conduction. So here it has a empty conduction but in conductors it will be the filled one, and they have almost filled valence band, and the energy gap between the valence band and conduction band is very small, and they exhibit negative temperature coefficient of resistance. Negative temperature coefficient of resistance means if the temperature increases the resistance will decrease, and if the temperature decreases the resistance will be increased. And if we add any impurities to the semiconductor, its electrical conductivity will increase, and if the temperature of the semiconductor is increased, its electrical conductivity decreased. So these are the properties. So based on the properties only we will have the applications. So we'll discuss that applications in later. Then classification of a semiconductor. So here also we have two types, that is on the basis of composition of a material we can classify into two, that is elemental semiconductor or compound semiconductor. So elemental is nothing but the indirect band gap semiconductor. In other term we can call it as a indirect band gap semiconductor. And example for elemental semiconductors are silicon and germanium. And if we go with compound semiconductor, compound is nothing but combination of two or more, and here it can be also called as direct band gap semiconductor. So here we have some examples for inorganic gallium arsenide, cadmium sulfide, and gallium arsenic phosphide. So these are some examples. Then if we go with organic, means anthracene and doped methyl cyanosis. Organic polymers, so polypropyl, polyaniline, and polythiophene. So these are the some other examples for a compound semiconductor. So next we'll see the definition for elemental semiconductor or indirect band gap semiconductor. So it is nothing but they are composed of single species of a atom, that's from a silicon or germanium and tin. So usually it can be taken from the column 4 or taken from a 6 in the periodic table. So fourth column elements are silicon, germanium and tin, and sixth column elements are selenium, tellurium. So these are some example for sixth column. And then the compound semiconductor. So compound means a combination of two or more elements. So it can be combined group 3 and 5 elements or group 2 and 6th element. So for example, if we have gallium arsenide, indium phosphide, indium gallium, aluminum phosphide, so that have used for high frequency devices and optical devices.